This is 6.1. We're doing basic trig identities. So your basic trig identities is an equation involving a trigonometric function that is true for all the values of the expression. So these are things that we should know already, that sine's reciprocal is cosecant, cosine is secant, tangent is cotangent. Cosecant obviously then would be sine, secant would obviously be cosine, so cotangent is tangent. Other things that we should have talked about is that tangent is sine divided by cosine, which means that cotangent would be cosine over sine. So we're going to use these properties in order to find some of the answers down here. So cosecant's reciprocal is cosine. So if I flip this answer, I should get cosine's answer. So I'm going to get negative 3 over square root of 30. Now for my class, remember, I don't care, that's fine. But if you're on an ACT or something and you need to rationalize the denominator, you multiply top and bottom by square root of 30. So you get negative 3 radical 30 over 30. And then that right there reduces negative radical 3 over 10. So for the next one, I'm given tangent and cosine. I'm trying to find sine. So I'm going to use this function right here. So tangent equals sine over cosine. So tangent is radical that over 4 equals my sine. I'm not sure, so I'm going to put sine of x here, divided by cosine of x, which is this, 2 radical 3 over 3. So if I cross multiply these two terms right here, I'd get radical 2 times 2 radical 3 over 3 equals 4 sine of x. So I'm going to simplify this side before I bring over my 4. So this right here would be 2 over 3 times radical 6. Did I write something down wrong here? Oh, yes, this was a radical 2. I don't know where I got the radical 3 from. Silly me, radical 2, radical 2. So then this would be radical 2 times radical 2 would be a radical 4, which makes that a 2. So 2 times 2, so we get 4/3 equals 4 sine of x. Divide your 4 over, and we get 1/3 equals, where was there a negative? And then I dropped the negative also. And so there's a negative here. Oh, how many mistakes can I make in one problem? You guys can tell me. All right, so it's the same idea down here for cotangent. Cotangent, I would need cosine over sine. So if this is cosecant, then that tells me that sine of x equals 3 over 7. And then to find cosecant, or find secant, I'm going to find cosine of x first. So cotangent is negative 2 radical 10 over 3. Cosine of x, I don't know. Sine of x is 3/7. I'm going to cross multiply these. So now I get negative 2. Actually, let's multiply a negative 2 times 3. So negative 6 radical 10 over 7 equals 3 cosine of x. So divide my 3 over right here. And then get negative 3, negative 2 radical 10 over 7. That equals cosine of x. So if I want to find secant of x, I just do the reciprocal of this. So I'm going to get negative 7 over 2 radical 10. I'm fine with that as an answer, but we'll practice reducing it for the ACT type stuff. So multiply top and bottom by square root of 10. So negative 7 square root of 10 over 20. Okay, Pythagorean identities. So remember, sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. So if I know sine of x, and I'm trying to find any of these, so if I have sine of x, I can find cosine of x using this property right here. So it tells me that sine squared of my theta plus cosine squared of theta has to equal 1. So then that tells me that negative 1/3 squared plus cosine squared theta equals 1. So that's 1/9. So minus over 1/9. And I get cosine squared theta equals 8/9. So if I square root both those sides, I get plus or minus the square root of 8/9 square at the top, and I'm going to reduce the bottom. So this breaks into 2 radical 2. Okay. And so that is plus and minus. So then we need to see up here. So if cosine is negative, so cosine is negative, where we have 1, 2, 3, 4. Sine is negative in 3 or 4. And then it tells you that tangent is cotangent is also negative. So that puts me in quadrant 4 here. So that means that sine is positive in that quadrant. So we're going to keep the positive of that. And so now, let's see, we're trying to find tangent squared. So if we know tangent squared, I'm going to use this one right here. So tangent squared would be, let's see, so tangent squared. So tan squared theta plus 1 equals my secant squared. So secant squared is just going to be this answer flipped squared. So I'm going to have 3 over 2 radical 2 squared. So tan squared theta plus 1 equals 9 over, that would be 4 times 2, so it gives me 8. So minus my 1 over, so tangent squared theta equals 1/8. So then I'm going to square root both sides. So tangent theta would be plus or minus the square root of 1/8, which equals plus or minus, that's 1 over 2 radical 2. And then tangent, we know cotangent's negative, so tangent would also have to be negative there. If you wanted to rationalize the denominator, you would multiply top and bottom by radical 2. So you'd have negative radical 2 over 4. Okay. Right, over here, the tangent and sine of theta. So if secant is 6/5, I know that cosine of x is 5/6. So if I know cosine is 5/6, I'm going to go ahead and find sine first because it tells me that sine squared of x plus my cosine squared of x equals 1. So sine squared of x, that would be 25/6 or 36. So do 1 minus that. So I'm going to do 1 minus 25 over 36 would give me 11. So I get 11/36. Square root both sides. So I get plus or minus square root of 11 over 6. And then I'm going to look and I'm going to say sine is positive, so I keep the positive right here. All right, so now to find tangent, if I'm given secant squared, I can just use this to find tangent squared. So I'm going to say tangent squared of x plus 1 equals my secant squared minus over my 1. The tangent squared of x is going to equal 11 over 25. Square root both sides. And we normally get plus or minus the square root of 11 over 5. And then we know that cosine is positive and sine is positive. The only time that both of those happens is if we're in quadrant 1, which means tangent is also positive there. So it equals a positive square root of 11 over 3. So on to the back. So we have these properties up here that we're just going to use. So if I have sine of a negative x, it tells me that it equals negative sine of x. So this right here is equal to negative sine of x. So sine of x, so negative sine of x would equal negative 0.97. So that tells me it's positive. And then if I want to find cosine of pi over 2 minus x, such as this property right here. So it's the exact same answer as the sine. So cosine of pi over 2 minus x is equal to the 0.97. So tangent of negative equals negative. So tangent of alpha would be 2.36 because it's the opposite. So cotangent and tangent are the same values. Or sorry, cotangent of alpha minus pi over 2 and tangent are the same values. That is right here. So that's going to also equal 2.36. Oh, wait, I wrote that backwards. Do you guys see that? Alpha minus pi over 2, and this is pi over 2 minus alpha. So if this is reversed, that means that this needs to be a negative sign right there. All right, so now if this is secant of beta minus pi over 2, so you see how that switched again? So then that would mean that it would be the negative of it here. So then we would say that it just says negative secant beta. So first thing I'm going to do is that I'm going to say secant of pi over 2 minus beta is going to equal the positive value of that. And then I know that secant of pi over 2 equals cosecant. So cosecant of my beta would equal 3.62. So if I'm going to do a negative of that angle, we look over here. Cosecant of a negative angle equals negative the angle there. So that means that cosecant a negative beta equals negative 3.62.